All right. Thanks for your patience, everyone. So yeah, we're here. Lisa's going to be presenting the second part of our beginner's crash course to the Elastic Stack. And if you want to go to the next slide, one thing I wanted to mention to you, and again, I will drop these links into the chat channel, is that we have a variety of avenues for you to get connected with the Elastic community. So one of them is through our meetups, which you are a part of right now. And you can find the latest meetups that we are holding all across the United States at our AMER virtual user group. So there's a QR code and link there. You can also join our Elastic Community Slack workspace, which has channels on every topic under the sun: machine learning, data science, observability, security, you name it. You can join a channel there. And there's also a job seeking channel. So if you're interested, if you're already an engineer who's familiar with Elastic and you're looking for a job, there's opportunities there. So definitely check that out. And then our community YouTube channel has many videos. If you're looking to learn more, dive deeper into a particular subject, we have playlists based on our solutions. And so the link and QR code are there as well. And then we also have, if you want to go to the next slide, Lisa, our contributor program. So we always invite folks to contribute to the Elastic community, either via blog posts or tutorials. You can do it via code submissions. Maybe you found a bug and you want to help fix it. So we recognize those folks with a program where you earn points for your contributions, and then we give you an award at the end of the cycle. So learn more about our contributor program by following that link and QR code. And then I think, was that it, Lisa?
I believe so.
Okay, awesome.
All
Carry
right.
on.
Okay, thanks, Phoebe. Hi, everybody. Welcome to the Beginner's Crash Course, the Elastic Stack. I'm Lisa, and I'm a developer advocate at Elastic. So last month, we kicked off the Beginner's Crash Course series. During the first workshop, we talked about the exciting use cases of the Elastic Stack. Then we dived straight into the architecture of Elasticsearch. Then we performed CRUD operations with Elasticsearch and Kibana. And today's workshop builds on the content of the first workshop. Now, if you missed the first one, not a big deal. On your screen, you have a link to a GitHub repo. And this repo contains a video of the first workshop, as well as 2 blogs that go over the same concepts. So if some of this stuff seems unfamiliar to you, then refer to this repo and get caught up afterwards. And Phoebe will post this link in the chat as we speak. Okay, so before we get started, let's do a quick recap. So if you're a developer working with data, the Elastic Stack is a great tool to have on your belt. Now, it consists of 4 products: Beats, Logstash, Elasticsearch, and Kibana. And with the stack, you could take data from any source in any format, then search, analyze, and visualize it in real time. So today we'll focus on Elasticsearch, which is the heart of the Elastic Stack. And this is a search and analytics engine that powers a lot of the apps that you use today. So for example, if you've ever searched for a restaurant on Yelp or searched for groceries on Instacart, Elasticsearch is the engine that is powering that search. So search is an experience, and whether you're searching for a documentation or your favorite show, you expect fast and relevant results no matter the scale. In the first workshop, we talked about how Elasticsearch allows you to get fast search results at scale. And today we'll talk about the relevance aspect of the search. So we search for things on a daily basis, and as developers, search is our lifeline, right? So whether we're fixing a bug or building a certain feature, we go straight to the search bar and hope that somebody has already figured it out and shared it online. Now, it's really frustrating when you're searching for an answer and you're not quite getting what you're looking for. And that is what relevance is all about. So when you search for something on your app, you want results that are directly related to what you're searching for. Which brings us to question, well, how do we measure the relevance of our search results? Now, two factors that we'll focus on are precision and recall. So let's delve into these a little bit more. As a quick review, we know that Elasticsearch is a search engine, and it allows us to store, search, and analyze data. And it stores data as documents, and documents that share similar traits are grouped into an index. So when you search for something, Elasticsearch retrieves relevant documents. Then it presents them as search results, which is highlighted in orange here. Now, on this slide, we have two diagrams depicting the same thing. So on the left, we have documents grouped into an index, and the same thing is shown on the diagram on the right. So the yellow rectangle represents your sample index, and the gray dots are documents contained in that index. I'm going to use a diagram on the right to explain precision and recall. But before we do that, let's go over some terms real quick. So when you send a search query to Elasticsearch, it retrieves documents that it considers relevant to the query. Now, these are the dots inside the white circle. And these are documents that Elasticsearch sends back as a response. Now, some of these retrieved documents are what you expect to see in your response, and these are known as true positives. Now, you probably had an experience where you search for something and some of the results were not relevant to what you're looking for. And these are known as false positives. So these are irrelevant search results that were retrieved by the search engine for some reason. Now let's focus on the dots in the yellow region of this diagram. Now these are documents that were not returned by the search engine. And some of them are truly irrelevant to the search query and were correctly rejected by the search engine. And these are known as true negatives. Now, among the rejected documents, there may be relevant documents that should have been returned in the response, and these are known as false negatives. So earlier, I've mentioned that precision and recall are used to measure the relevance of a search engine, and the term precision has to do with dots inside the white circle. And these are documents that are returned as search results. So precision is calculated by true positives divided by the sum of true positives and false positives. So what precision tells you is what portion of the retrieved data is actually relevant to the search query. Now, recall, on the other hand, is calculated by true positives divided by the sum of true positives and false negatives. And what recall tells you is what portion of relevant data is being returned as search results. So precision and recall are inversely related. Precision wants all the retrieved results to be a perfect match to the query, even if it means returning less or no documents. Whereas recall focuses more on quantity. So it wants to retrieve more results, even if the documents may not be a perfect match to the query. Now, the dilemma here is that we want to present really relevant items, but we also want to retrieve as many results as possible. So as you can see, these two factors are at odds with each other, because if you want to improve precision, it might cause a decline in recall, and vice versa. Okay, so let's recap real quick. Precision and recall determine which documents are included in the search results, but precision and recall do not determine which of these returned documents are more relevant than the other. This is determined by ranking. So when you look at your search results, you'll see that the most relevant results are at the top and the least relevant are at the bottom. And this ranking or order is determined by a scoring algorithm. So each result is given a score, and ones with the highest score are displayed at the top, whereas ones with the lowest score are displayed at the bottom. Now, score is a value that represents how relevant a document is to that specific query. And a score is computed for each document that is a hit. And hits are search results that are sent to the user. So the higher the score a document has, more relevant the document is to the query, and it's going to end up higher in the order. Now, there are multiple factors that are used to compute a document score. And for this workshop, we'll only focus on term frequency and inverse document frequency. So let's break this down. Now, when you search for something, you type in a search query in the search box, and Elasticsearch looks at the query and pulls up relevant documents or hits. Then it calculates a score for each document and ranks them by relevance. So how does this happen? Now let's talk about how term frequency plays a role in calculating a score. So here we have a search query, how to form good habits. And this query is made up of multiple search terms. So Elasticsearch will look through the return documents and calculate how many times each search term appears in a document. Now, this is known as term frequency. So if a document mentions search terms more frequently, Elasticsearch assumes that this document is more relevant to the search query, and it assigns a higher score to that document. So let's say we're looking at the frequency for the term habits. Now, in the field description of the first document, the term habits appears 4 times. Now, in the same field, in the second document, the term habits appears 1 time. So in this example, the first document will be given a higher score and end up higher on the search results. Now, when we calculate a score based on the term frequency alone, this will not give us the most relevant documents. Now, this happens because term frequency considers all search terms to be equally important when assessing the relevance of a document. So let's look at the search query here. We have search terms how, and to, and form, and good, and habits. Now, not all of these search terms will help you determine the relevance of a document. For example, the first 4 search terms are commonly seen in many, if not all, documents. So now if you look at the hits, then at the documents highlighted in orange, these documents like how to form a meetup group or good chicken recipes, they do contain some of the search terms, but these documents are completely irrelevant to what we're looking for. But because of term frequency, if these commonly found search terms were found in high frequency in any of these documents are going to end up with higher scores, even though these are irrelevant to the query. So Elasticsearch offsets this with inverse document frequency. So with Elasticsearch, if certain search terms are found in many documents in the results set, it knows that these terms are not useful at determining relevance. So when it goes through all the hits, it'll reduce the score for documents with unimportant search terms, and it'll increase the score for documents with important search terms like habits. So we just covered the basics of relevance. Next, we're going to fine-tune precision or recall of our search results. And we're going to do that by sending queries from Kibana to Elasticsearch. So in the first workshop, I went over how to download Elasticsearch and Kibana and run these locally on your own machine. And this option is free and there's no expiration date. But I found that when I run these locally and screen share at the same time, Zoom slows everything down. So like live demo is almost impossible. So when I run these on Elastic Cloud, it seems to do better while screen sharing. So this time I'll show you how to get set up on Elastic Cloud. So I'm going to breeze over this setup. I don't expect you to set this up during the presentation. I just want to show you what you need to do. So if you want to try this on your own, you can watch the recording and get started. Okay, so here we have a link to the GitHub repo for today's workshop. So Phoebe, will you drop the link in the chat? I think you did a little bit earlier. But
I did, but I'll do it again just in case anybody missed that. Yep.
Okay, so go to this link and have this pulled up. Now you'll see this on your screen. So this repo contains all the resources that are shared during this workshop, and the slides and the recording of this workshop will be included here as well. Now, if you scroll down to the resources section, you'll see the link to free Elastic Cloud trial. You'll right-click on that and open the link in a new tab. Now, the link will take you to the free trial page, and Elastic Cloud hosts Elasticsearch and Kibana as a service. And unlike the downloaded option, it does all the heavy lifting of managing the stack. So you usually get a free trial for 14 days, but the link in the repo will give you access to it for 30 days. Now, there's no credit card required, and the trial will expire on its own. So to get going, enter your email and click on Start Free Trial. And once you do that, it'll ask you to go to the email account you signed up with and verify your email. So go to your inbox and click on the email from Elastic, then click on Verify and Accept button. And it'll prompt you to set your password. And once you set your password and log in, it'll take you to this page where you'll click on Start Free Trial. Next, you'll select the Elastic Stack. When you do that, you'll see this drop-down menu where you can configure your settings. So if you look under Select Hardware Profile, Elasticsearch offers several deployment templates for different use cases and workload. And each template selects the appropriate cloud hardware configuration for different needs. But if you're just getting started or don't quite know your needs yet, then go with a recommended IO optimized option. Then you choose a cloud provider of your choice. So let's say you have an app and you want to integrate Elasticsearch. But if your app is running on Google Cloud, you don't want Elasticsearch running in a different cloud provider because that'll cause latency issues. But for what we're about to do, it doesn't matter which one you choose. So just select one. Then select the region close to you. And select the latest version of the Elastic Stack, which at the moment is 7.10.1. So if you scroll down, you can name your deployment to whatever you want. I named mine Beginner's Crash Course. Then click on Create Deployment. Now, once you do that, you'll get your deployment credentials, and you'll need this when you add data to Kibana. So either download the credentials or save it somewhere else, as these are only shown once. And when you click on download or continue without downloading, it'll create your deployment and load Kibana. So once everything is loaded, click on Open Kibana. And after that, both Elasticsearch and Kibana are ready to go. Now, when you advance to the next page, click on Explore on My Own option. Then it'll take you to this home page. So in order for us to explore the relevance of our search, we need to put some data into Elasticsearch so we have something to search for. Now, if you have your own data in CSV, NDJSON, or log file, it's really simple to get data into Elasticsearch. So scroll down on the home page and click on Upload a File option. And for our tutorial, I'll be using a news category dataset from Kaggle. And this dataset contains news headlines from HuffPost from the year 2012 through 2018. Now, I included a link to the dataset in the GitHub repo. So if you want to try it out on your own later, you know where to find it. So just make sure you download and unzip the data first, then drag and drop the dataset here. Okay, So once you do that, Kibana will give you an analysis of the first 1,000 lines of your data and give you a summary of your data set. So if you look at our file content, you'll see several documents of news headlines under different categories like crime or entertainment. And on their summary, we also see that our data is in NDJSON format and the time field is date. And when you scroll down, you'll see the field section. And in this data set, each document contains fields such as authors, categories, headlines, and etc. And we also see some high-level statistics for each one. So scroll down and click on Import button, and this will import your data into Elasticsearch. And when we're pushing data into Elasticsearch, it'll group all documents into an index so we could easily find it. So give your index a name. I named my news headlines all lowercase, then clicked on Import. Then Elastic Cloud takes care of the rest. So you have data in Elasticsearch, and you also have Kibana up and running. And Kibana is a UI used to visualize and explore data in Elasticsearch. So for our tutorial, we'll use the Kibana console to search for data and improve the precision or recall of our search results. So click on the menu icon in the upper left corner. And in the drop-down menu, scroll all the way down to Management section and click on DevTools. And this will pull up the Kibana console. So click on Dismiss and delete the default query here. And now we're finally ready to get started, right? Okay, let me get organized here real quick. Okay, so I have two windows open side by side. On the left, I have the Kibana console, and on the right, I have our workshop repo. So we have two goals. One is to search for information, and two is to fine-tune precision or recall of our search results. And we'll be using Elasticsearch and Kibana to get these done. Now, we just got data into Elasticsearch, so all we have to do is to use Kibana to send search requests to Elasticsearch. So let's start by exploring our data first. Now, when we added data to Elasticsearch, it stored our data in an index called news headlines. And we want to get a feel for our data, so knowing what our document actually looks like or how many documents we have would be really helpful. Now, there's a query that gets you that information. So go to your repo and scroll down to search for information, then down to retrieve all documents from an index. So for every request we'll cover, I included the general syntax for you, so you could customize this for your own use case. But for our tutorial, we'll use a request shown in the example. So what we're saying here is get search results from index news headlines. So we'll copy and paste that into our console. Make sure to click and select it, and there's a dark gray bar over it, and click on this green arrow to send the request. Now, what this does is it'll give you information of all documents in the news headlines index. So in the right panel, you'll see the search results from Elasticsearch. And if you scroll down to line 16, it gives you a sample of 10 search results by default. So let's scroll through and see like what documents we have here. Anything interesting? All right, let's pick this one. So this document is from index news headlines. And if you look under source, you'll see all the fields or content that this document contains. So it shows the date when the article was published, the link to the article, category, headlines, and etc. So with this search request, you get a general idea of what a document looks like, so we know what we're dealing with. So let's see how many documents that we have. So go back to line 10. Now, it tells you the total value of hits is 10,000. Now, by default, Elasticsearch limits the total count to 10,000. And this is done to improve the response speed on large data sets. So to see if 10,000 is the exact total number of hits you have, then check the relation field below. Now, if you see an EQ in this field, that means the value is equal to the total number of hits. But we see GTE, which means that our number of hits may be greater than or equal to 10,000. So let's say we want to know the exact total number of hits. So to do that, look at your repo and scroll down to get exact total number of hits and down to the example. Now, this is almost identical to the request that we just sent. So we're saying, hey, I want to get search headlines. By the way, I want the exact total number of hits in the response. So let's copy and paste that. Make sure to select it and send. Okay. So depending on how big the data set is, this query may have a slower response time. So if you look at line 10 hits, you'll see that the value is now 200,853. And if you look at relation, you see EQ, which means that this is the exact total number of hits. So we have over 200,000 article headlines, and we want to find interesting patterns in our data, but it's hard to know where to even start. So one way to narrow it down is to search for data within a specific time range that you're interested in. So let's scroll down to search for data within specific time range and down to example. So there are two main ways to search in Elasticsearch, and these are queries and aggregations. So queries tell Elasticsearch to retrieve documents that match the criteria. And right now, we're searching for documents that match our time range criteria. So for our use case, we need to send a query. So this is the query that we're going to send. We start by get search results from news headlines. Now, I'm querying data from certain time period. So the type of query that I'm sending is range. And the following are criteria that for documents in my search results. So I want you to only look at the date field and pull up all the articles that have been published between these two dates. So let's copy and paste that into our console. Make sure to select it and send. Okay. So you'll see that we got over 8,000 hits. And if we were to look through all these documents and look at the date field, where is that? You'll see that all of the documents have been published between the time range that we have specified. All right. So how can we narrow down our search? Well, when you look at documents in our search results, we see that these articles belong in different categories. So if you look, this one belongs in media, and the other one, let's see, it belongs to parents category. So to explore our data further, it'd be really helpful if we knew what type of news categories exist in our data set. So let's scroll down to aggregation section. Now remember, there are two main ways to search in Elasticsearch, and these are queries and aggregations. And queries are used to retrieve documents that meet the criteria. But in this case, we're not interested in grabbing documents. What we want to know is a type of news categories that exist in our data set. So to get this information, we need to analyze the data and get the summary of categories that exist in our data. And this type of search is known as aggregation. So this time, we'll send an aggregations request. So turn to your repo and scroll down to example. So the aggregations request is pretty similar to the query request that we just sent. So we're saying, hey, I want to get search results from news headlines. I'm sending an aggregations request, and I want you to name this report by category. Now you're going to run an analysis on the following terms, and that term is field category. And bring me up to 100 categories if you got them. So let's copy and paste that into the console. Make sure to select it and send. Now you're going to go to line 10 and click on this downward arrow to minimize it. Then you'll access the aggregations report that we named by category. And if you look at field buckets, you'll see an array of all the categories that exist in our data set. So it seems like we got politics here, wellness, entertainment, and travel. And each category has document count, which tells you how many articles have been written for that specific category. So now we have a lot more to work with. So let's scroll down to combination of query and aggregation request and scroll down to examples. So it seems like the entertainment category contains a lot of articles, and I want to explore that a little bit more. So what if I wanted to identify the most popular topics in an entertainment category? Now this is a combo of both query and aggregations requests. Because first, you got to pull all the documents from the entertainment category. So you got to query the data first. Then you have to analyze query data and give the summary of the most significant topics in the entertainment category. So let's go down to the example here. So what we're saying is get search results from news headlines index. First, I'm sending a query request. Now, I want you to bring me all the documents that match the following criteria. And the documents will be from category entertainment. Then second, I want you to run aggregations on the documents that we just queried. And I want this report to be named popular in entertainment. And I want you to run an analysis on the significant text that is found in field headline. So let's copy and paste this into our console here. Make sure to select it and send. Now go to line 10, minimize it, and you'll get access to aggregations report that is named popular in entertainment. And under buckets, you'll see an array of all the popular terms in our entertainment category. So it seems like the word trailer is pretty significant. It's been found in 387 headlines. It seems like movie is one, Taylor's one, and Kardashian is one. So one of my guilty pleasures is watching Keeping Up with the Kardashians. So I'm going to look up articles that mention Khloe Kardashian and Kendall Jenner. So scroll down to precision and recall and down to examples here. Okay, so I'm going to send this query here. So what this is saying is get search results from news headlines index. Now I want you to query all the data that matches the following criteria. Now bring me all documents that contain these search terms in the headline field. So let's copy and paste that into our console. Select it and send. Okay. Now you'll see that there's a total of 926 hits. So let's go over the search results. Okay, so this is the first document here. I'm going to look at the headline. So it seems like all 4 search terms have been found in the headline, so that's good. Now let's look at the second one. All right, we have Kendall Jenner, but no Khloe Kardashian. Let's look further down. Let's see. How about this one? Okay. So this one has Kendall Jenner, but instead of Khloe, we have Kourtney Kardashian. So kind of relevant, but not really. The next one. Now, it's talking about Nick Jonas and Kendall Jenner. So our search results, we turned a lot of articles that mention some of these search terms, but these are not perfect matches to the query. Well, why is that happening? So notice that our search query contains 4 search terms: Khloe and Kardashian, or Kendall, or Jenner. Now, by default, the match query uses an OR logic. So with this query, a document is considered as a hit if it contains even one of these search terms in the headline. Now, earlier, we went over the concepts of precision and recall. So I've got a question for all of you. So is this query better for improving precision or recall? I want you to type the answer in the chat box. Okay, button says recall. Anybody else? Recall. Okay. All right, so you guys have been paying attention. So the correct answer is recall. So by default, our match query uses an OR logic. So if a document has at least one of these search terms, it's going to be a hit. And because of that, we have high recall because we get an increased number of loosely related hits coming our way. Now, what if we wanted to increase precision instead? So let's scroll down to increasing precision and down to example. So we can increase precision by adding an AND operator. So we're using almost the identical query that we just sent, except that we added an operator parameter AND. And what this is saying is only pull up documents that contain all 4 of these search terms in the headlines. So let's copy and paste this into our console. Oops. One second. All right, there you go. Send. Okay. So with the previous query, we got 926 results. But with this query, we got 1. So once you scroll down to this one document that we got and look at the headlines, you'll see that all 4 search terms are in the headlines. And this is a perfect match. So we definitely improved our precision for sure. But it feels like with our first query, we widened our net too much, and we're getting a lot of loosely related search results. But with our second query, we were way too strict and got 1 match. So is there a way to land somewhere in between? And the answer is yes. So you can use minimum should match parameter. So scroll down to that section. Okay, so this parameter allows you to specify the minimum number of terms a document should have to be included in the search results. And this gives you more control over fine-tuning precision and recall. So let's scroll down to example. And this query is almost identical to the query that we just sent. We just replaced the operator parameter with minimum should match, and we set this equal to 3. So what we're saying here is for all the hits, at least 3 search terms must be included in the headlines. Now, of course, you could change this number as well, but we're going to copy and paste this request. Make sure to select it and send. Okay. So now we got 6 results this time. So compared to our last query, we improved the recall. And if you look at the documents, let's see here. All right, so the first one has all 4 search terms. Great. The second one, it's got 1, 2, 3. Okay. And the third one has 1, 2, 3, 4. So we have at least 2 articles that are precise matches to the query. So we improved our precision as well. So the minimum should match parameter is a great way to narrow the net without being too strict. So this is a good parameter to use when you're fine-tuning precision and recall. So those are all the queries that I got for you. Now, we went over a lot. So let me see if you guys asked any questions in the Q&A section. So Christian asked, can you combine rank or score with sort? And this is totally my bad, Christian. I should have asked a follow-up question to understand your question better. Now, documents are sorted by score by default. So I interpret your question as, if you have several different queries to sort the results, can you combine it into one request? And if that was your question, the answer is yes. So this actually has to do with the content of our future workshops, so I'll give you a sneak peek. Now I'm going to show you a bool query as an example, and this query combines multiple queries into one, and it allows you to sort the data even further. And with this query, you have 4 clauses to choose from, and these are must, must not, should, and filter. And you can build a combination of one or more of these clauses to sort the data even further. For example, you can include what terms a hit must or must not contain. And you could include the terms under should. And if these terms are included in the hits, you could increase the score of the hits and list them higher in the search results. And you could also apply a filter to exclude any documents that do not match the criteria. Now, we'll cover this more in depth in the future workshops, so I won't go more into it. But the point that I'm trying to make is that yes, you can combine multiple queries into one request to sort the data even further. And there are multiple different ways to do that beyond what's been shown here. So Christian, if that wasn't the question you were asking, feel free to reach out to me via email and I'll get your question answered for you. Now, Pedro asked, do you know how to delete the imported data set to import a new one? And the answer is yes. So during the workshop, when we imported the data, we created an index called news headlines. And our data was indexed into the news headlines index. So to delete the data, you can just delete the index. So it's simple as sending a delete request via the Kibana console. So the syntax that you're going to use is delete followed by the name of your index you're trying to delete. And once you send the request, if you see acknowledge true as a response, it means that your data set was deleted. Now, I usually double check by sending a GET request to the index I just deleted. And the syntax I'm going to use for that is GET followed by name of the index, then the search endpoint. And once you send the request, if you see an error in the response and it says index not found, that means that your data set has been deleted. So to import a new one, you could follow the steps I showed during the presentation. Now, I thought you might be asking in the context of replacing the old data set with a new one and using the same index name and index pattern. Now, an index pattern is a collection of one or more indices that contain the data you want to visualize, and this feature allows you to explore multiple indices at one time. And Elastic Cloud automatically creates an index pattern for you when you create an index. So if you're trying to use the same index name with a new data set, you're going to run into an error that says the index pattern already exists. So in this case, you'll have to delete the index pattern before importing new data with the same index name. So click on the menu icon in the upper left corner and click on Home. Then on the home page, click on Manage option. then you'll see a list of index patterns on your screen. So click on the index pattern that you want to delete. Then click on the delete button. Then you should be able to import new data set and still use the same index name and index pattern. Now, Stephen asked, when you did the manual import from file, does it let you adjust the mapping? Yes. So those of you who are not familiar with mapping, it's a schema definition that contains the names and data types of the fields of an index. So let's go back to when we're uploading the data set during the presentation. So when you drag and drop your data set here, Kibana will give you the file contents and summary of your data set. Now there's an option called Override Settings. Click on this option here. Then you'll get this pop-up menu, and you can scroll down to edit the field names here and click on Apply. And once you do that, you'll click on Import button. Then it'll take you to this page. And the next steps will be identical to what we went over during the presentation. But if you want to adjust the mapping even further, you can click on the Advanced option. And here you can name your index, adjust the mapping, and import. And again, steps after this will be identical to what we went over during the presentation. Okay, so that was the last question in the Q&A session, so we'll start wrapping up. So we have another workshop in the series coming up, and we'll be talking about full text queries and how we can customize search even more. And this is happening on Wednesday, February 24th at 12 p.m. Central Time. And the details will be posted on our meetup page in the upcoming weeks. And it's called Elastic Austin User Group, and the link to this page is included in the repo. Now, if you have questions about Elastic, the discussion forum is a great place to get your questions answered. And we have a community of developers and developer advocates that answer questions on this platform. So feel free to post your questions here. And last but not least, I often blog about Elasticsearch. So if you prefer to learn by reading instead, be sure to check out my blog. All right, that's a wrap. So thank you so much for coming, and I'll see you later.